Welcome back to We Build, We Learn. Today's episode is a response to Ham Radio Dude's challenge. It is the Thrift Stop challenge where we have to go to a thrift store and find something that we can convert into a CW keyer. So today I am doing this remote control excavator. Now, I have to say I might be disqualified because unfortunately right now, as of the 26th of May of 2021, we are still under lockdown orders and thrift stores are not open. So I had to go into my basement and find something that is not working anymore that I can make into a CW keyer for this challenge, and then hopefully one day fix it like all the rest of the things that I have to fix. But for now, let's go inside to the shack and see what we can do.
I'm trying to make this into my keyer. What would be awesome is not only be able to make this into my keyer, maybe like this button here, but maybe if I can change the VFO. Wouldn't that be cool? All right, let's see what this is. Let's open it up and take a look at it. All right, guys, so there is nothing worse, in my opinion, than trying to watch yourself while you're editing, and then you critique, and then you're not happy with what you said, and I'm going to add some voiceovers and some video clips as we go along to try and help you guys better understand what we're doing, as well as to make sense of what's happening. So right now what we have to do is we have to remove these two levers that are actually what make contact with the switches for the, the motion of this toy, but what we're going to use for the VFO. Now, at first glance, I'm very happy with what I see. These are really basic switches, in my opinion, as well as the circuitry. The circuit board itself is, there's nothing really big there. It's actually just a very simple circuit board, and it's going to make it easy for us to sort of tap into it and do what we want to with these switches. Look at that. Super easy to make, to solder. So, okay, so these switches here are, let's see what they are. You see that? So you have a normally closed and a normally open circuit. So we would want to go to a normally open circuit, and then when we make contact, it would close the circuit. All right, guys, let's take a second and talk about normally open and normally closed circuits for those of you who don't quite know what they are. Now, normally is referring to its default position. So when you're not engaged in that switch, it is normally either open or closed. So the one that's open does not have a clear path for the flow of electricity or electrons, and the one that is closed does. And when you engage that switch, it does the opposite. So the closed opens and the open one closes. And that's what a normally open circuit is. And typically these circuits, these especially switches that have both actions in the same switch, those are actually used for safety in equipment or machinery, so that you don't tell a motor to do two opposing actions at the same time, and obviously causing big issues down the line. So for instance, in garage door openers, so you can't push the up button and the down button at the same time. It's kind of like a lockout feature that inhibits that. Once you push that up button, that down button won't work anymore. And once you push that down button, that up button won't work anymore. And it's a safety feature also, like it is inside of this controller, where it's protecting the electronics inside, particularly the motor, that if you're turning it left, you can't start to tell it to turn right instead. All right, so now that we know what normally open and normally closed circuits are, we have chosen to use the normally open circuit. This will mean that the flow of electricity or the shorting to ground that is going to be needing to take place in order to control the VFO is only done when we engage that switch. So we need to connect some leads to these terminals so that we can actually do something with this switch. And so I'm soldering on some wires so that we can then take that and incorporate it into our circuitry. That's going to eventually go back to our rig. Okay, so we have our VFO up and down wired in, okay? So now we're gonna try, and I'm right-handed, so I'm gonna make these all CW keys. Okay, we're gonna adjust our solder again. Okay. Very good. So now, checking for continuity. Put on the probe. Put it on the probe. Would you look at that? Awesome. Not that great of soldering going on here, but awesome. Okay, so let's take a look at what I've done here. My camera died for a second there. So what I've done is I want to have all 4 switches in the front. 1, 2, 3, 4. I want them to be able to run the keyer, or be the keyer, I should say. So because the contacts are so small, what I've done was instead of jumping one to the next, I've come back, I've branched them all to one, and this will go off to our connector to go to the keyer. So they're all soldered. I have the leads all connected. So what I want to do is just go across and test them all one at a time. Not the best switch, but it's going to have to do. So now that we know which wires are what, we have our switches taken care of. It's just really simply a question of doing the final wiring to the rig. So for the switches that are going to be our keyers, we really only have to connect that to a 1/4-inch jack to send the signal to the rig, and we're all good. Now for the VFO control, we just got to make sure we go to the proper pins on our connector that goes to our radio, and everything's taken care of. But now it wasn't long after this that I realized that I made a mistake, and I was going to have to redo everything I did up until this point. Now the issue that I had was my connector that I was using for my keyer was not compatible with my Yaesu radio. And it's internally that's not compatible. It's the right size cable, but the problem is that inside the Yaesu, it's made for 3 points of contact. That is for the signal 1, signal 2, and the ground that you would see in a paddle keyer. And when you push the one paddle, it would make a dit, and when you push the other one, it would make a da. That would take 2 signal wires or 2 contacts inside the connector to have that full functionality. Now, when I was plugging this 1/4-inch in, which is a mono one, there is missing one of those contacts or the separation, and it was automatically grounding or shorting to ground that signal wire. And it was putting out dits or DAWs. I forget which one it was, but it was putting one out, and that caused a problem. So my IC725, which is an older radio, it actually works with this cable, so I had to redo everything from this point on to make it compatible with that radio. But before we do, I have a little clip of the moment that I realized that there was an issue with this connector. All right, we're on a clear frequency. I do not have a dummy load. We're going to test this out. Whoops. So by changing to my IC725, I also have to deal with the control for the VFO. Now on the Yaesu, pin 1 is VFO up, pin 3 is VFO down, and pin 5 is the ground. And ICOM is completely different in not only which pin is what, but the idea that it's only one pin for the VFO control. You see, on the IC725, VFO control is only that one pin, whether it's for up or for down. Now in the manual, it shows it pretty clearly that in order to go VFO up, it's a straight short to ground, and VFO down, you have to go through a 470 ohm resistor. So what we're going to do now is we are going to change the wiring inside the radio, which you didn't see, but I'm going to spare you that. I'm going to show you the wiring in order to control the VFO on the IC725, and then we're going to finish up this project and we're going to test it out. All right, let's make this quick. So as you can see, I had pretty much finished this project when I realized that there was this mistake. The connectors, fortunately, on both the Yaesu and on the ICOM are identical 8-pin connectors, and so I could salvage that and not be delayed in this project. Now, the pin schematics are completely different for both radios, so I had to desolder some of the pins. And as you can see here, I'm cutting the wires because both up and down VFO controller have to go back to the same pin, except for the down needs a 470 ohm resistor in line with it. Okay, so I actually tested it a couple ways. I actually tested the whole thing. And so you can see here I have my resistor in line. So I'm going to just solder these together. I'll put some sort of connector on that or some kind of protection. Here, listen, this isn't a permanent key. I might just tape the whole thing. I'll solder it and then I'll protect it somehow so it doesn't short. So at this point, we essentially have a fully functioning CW key. It's not closed up and the cable's not connected, but that's really all that a CW key is and a VFO controller is literally switches, and that's it. We are closing circuits and opening circuits, and that's all that is for both the CW keyer and for the VFO controller. So there's a lot of little details that I didn't include in this video because I don't want to make this a 30, 40, or an hour long film. I wanted it to be a quick project where we learn some little things, some little bits of knowledge along the way. And I think we succeeded in that. But, you know, this isn't complete until we test it and make sure it's working. So let's go test it. And that's pretty much the project, guys. All right, guys, first I'm going to show you the key. So all right, so that's the keyer. And then I'll show you that it has VFO control. So give me 30 seconds. I'm just going to plug it in the front, and then we'll get to that. All right, so we're at 35, 33, and we're going to go up. I'm pushing up on this, and then we'll come down. So we can change our frequency. So that's it, guys. That's my response to the Ham Radio Dude Goodwill Keyer Challenge. I hope you enjoyed it. And now I'm going to put this thing back into its original condition so it can be used by kids. So thank you very much for watching, and hope you subscribe, like, and comment.